can have one. We have books. Okay, so we're going to start with polygons. Okay. I have one over there someplace. Yeah. It's orange. It's right over there behind them. Yeah. Okay. A polygon. Okay, guys, you know a lot of this, but we'll review it. You don't know all of it. There's a lot of vocabulary here today. Okay, Zach? Okay, a polygon is a closed figure in a plane. So if I take a figure like this is not closed. Okay? It has to be all connected. Then you have a polygon. And we're going to connect the line segments endpoint to endpoint with each segment. Just know what it looks like. Don't worry about defining it. TJ, we have a seat? Yes, but you're in the way. Okay, so on the left side of my screen are the polygons, and the right side of the screen are not. Now, this is not a polygon because it's not made up of line segments. Sydney, calm down. Okay, you guys ready? So we get through this? You shouldn't have homework, or if any, you shouldn't have much. Okay, this isn't a closed figure. If I did that, then you could maybe call it a polygon. Okay, that's like a circle. Circles are not polygons. Okay, do you remember the names of the polygons? A three-sided figure, you should know that. Triangle. In the homework, you have to identify some things. Okay, does anybody know what a four-sided figure is called? Eric, do you remember what it's called? It starts with a Q. Quadrilateral. Excellent. Lateral means side. It comes from the Latin. And quad means four, so it's a four-sided figure. What's a five? Everybody should know this one. We have this in Washington, D.C., the Pentagon. Washington, D.C. Uh-huh. Six. Now, the reason why I know what six is six has the letter X in it. So this word has the letter X in it. Hexagon. Seven. There's two ways to name this if you want what do you guys call seven? A septagon. That's the French one. An engon. But we have to know some of these names. Heptagon. I think that might be Latin. Set is French for seven. So I know that one. It doesn't matter. I'll take either one.
You guys are being extremely disrespectful.
I don't know. I'm watching them. Okay, what's an eight-sided figure?
What sign is it on? Is it a heptagon?
It's either one. They're both right. One's from Latin, one's from French. This is an octagon. What familiar shape is an octagon? Stop sign. Okay, you remember what 9 is? Nonagon. Well, it has almost the word 9 in it. That's how I remember it. And you all know 10. Decagon.
I didn't know that.
Decade is 10 years. Dec means 10. Decimal system is based on base 10. 11, I doubt you're going to know that one. Undecagon. I don't know if I'm spelling it right, though. Undecagon. Un means one in French. And then, so it's 1 plus 10, so that's 11. And 2 is duo or do. You say dodecagon. Sometimes spelled without the U, by the way. So, right. So it's 2 plus 10 gives you 12. And if you have any number of sides, we call it an n-gon. So if you had 17 sides, There's no special name. It would be a 17 gun. Should be hard to draw. 17 gun. Mm-hmm. True, but it's nice to know the names. And you don't know the names for the most part. Okay, so we have names of all our different polygons. Ready? Now, how do you name a polygon? The order, it doesn't really matter where you start, but you have to go around either clockwise or counterclockwise. You have to go in consecutive order. Consecutive means you can't jump across. You just got to go to the one right next door. So if I start at A, I can do A. I'd like to go this way. Then B follows C, D, and E. If I want to go the other way, it would be A, E, D, C, B. You just have to go in consecutive order, the one right next to the last one you just did. Do I have to start with A? No. So you want to give me one? What do you want to start with? E, D, C, B, A. There's a lot of ways to name these. Lots of ways. Okay? Now that order, once you choose a vertex, they don't define that, but this is the vertex, then you either go one way or the other. But I know once I choose a vertex, that if I connect these two vertices, that's the side AB. There it is, in my name. Okay, Karen? So this is a side DE that would represent this side. Well, that's gonna come into play later on in this hour. So you get the sides if you take these two consecutive letters together. That gives you all the sides. And we're going to match them up. And that's how you're going to do some of the problems. Because sometimes it's hard to figure out how polygons match. Now, this is the only one that gets a little symbol. It's the triangle. Then you get a triangle symbol. Now, it doesn't matter what letter you start with. You can't do this one wrong. Unless you don't use all three letters. TSU, triangle TUS, and triangle UTS, and then you can reverse the order. So there's a lot of ways to name the triangle. If I'm talking about angle S, now that matters. And I would call angle S angle TSU or UST. So when I name a triangle, it isn't going to matter. But when I name an angle, it does matter where the vertex is. Is that okay? Is that clear? And some of you didn't know the vocabulary on your test, so you didn't answer the question. So you have to know this vocabulary. Okay, a lot of stuff here on parts of a polygon. These are the vertices. That's the vertex A. And it's consecutive. It's right next to B. And E is the other neighbor. Oh, sorry, not E, it's F is the other neighbor. Then consecutive sides. This is a consecutive side, AB, and then you have BC. They share a common vertex or common endpoint. And we can do the same with the angles. You can talk about angle A. What's right next to angle A? I can go either direction. Angle B or angle F. Yeah, everything's consecutive there. Angle B or angle A and angle F. And that's going to be important because we might have you draw something and you're going to say, well, I want consecutive. Well, whoever's drawing it has to understand what that means. So we'll find that out. 100, if it's a regular hexagon, it's 120 degrees there. Looks like 120, doesn't it? Okay, ready? Now, why diagonals are talked about now? I don't know. We've been talking about diagonals. But diagonals do not draw to their neighbors. They don't go to the consecutive vertices. So if I draw the diagonal from A, I'm not going to do A to M or A to T. A diagonal has to connect vertices that are not right next door. So from vertex A, there's 3 diagonals I can draw. How about T? Remember doing this problem? We can't draw an A. It's not a diagonal. T to M, T to E, T to S. And I could draw a whole bunch of them, couldn't I? There's a little bit of it in there. Because now if I draw from H, I don't want the repeats. H. So how many vertices are there? In this picture, how many vertices are there? 1, 2, okay, there's 6. How many diagonals can I draw from any one vertex? I can draw 3, which gives me 18, but the problem is I've got the double colors. I don't want the double colors. So what do we have to do? Divide by what? 2. So there would be 9 distinct diagonals in a hexagon. I just answered a homework question. I'll let you feel. We did this problem before. So we should have defined a diagonal before. Now we have the formal definition. Yeah, you won't have constructions. You won't have the constructions. You don't like the constructions. I like those with the compasses. Because they're not, unless they're later in the year, I don't think they're coming again. Bisecting an angle? Yeah, we aren't doing that anymore. You can still do it. Okay. Now, we have 2 kinds of polygons, a convex and a concave. And the way, and you just have to recognize it. The way this definition is if you draw a diagonal will be totally inside the polygon. What kind of shape is this 4-sided figure? Quadrilateral. And I can draw that diagonal and that diagonal. And the diagonal totally lies inside the shape. How many diagonals for a triangle? No diagonals. Okay, and if I draw this looks like a square. I'm not exactly sure if it is because I don't know. It might not even be a rectangle. So if I try to draw the diagonal here, I can certainly draw that one. It's inside. But what about this one? That's outside. This is called a concave polygon, and I don't think we do very much with those. And let's see. Let's draw the diagonals on this next one. That one lies outside, that one lies outside, that one lies outside. So that is a concave polygon. But our theorems have to do with the convex ones. Now, you don't have to be able to define that. You just have to be able to recognize it. Is it okay, Phoebe? And then you can go to, ready to go to the next page? Now, be careful with these. And these are more new words. We have to know what they stand for. You know, lateral means side. Comes from Latin. Lateral pass in football is not a forward pass. It can go back, but generally speaking, I'm thinking of it as a sideways pass. And this is equal. So all the sides are equal. Now be careful with the pictures. It looks like all the angles are congruent. Can you draw a figure with 4 sides that are all equal? But the sides have, okay, parallelogram. All the sides are equal, but I don't have congruent angles. These are all equal. Does anybody remember what that's called? A rhombus. Are these angles, is this angle congruent to that angle? Yes. Look at it. That's obtuse. That's acute. No. So just because it's equilateral doesn't mean all the angles are equal. And the word for equal, if all the angles are equal, is equiangular. So the answer to this question is no, not for sure. Whereas an equiangular polygon, all the angles are equal. All angles are equal. Necessarily, if all the angles are equal, does it have to be equilateral? Can you think of a four-sided figure that looks like a square? Can you think of another one that has all right angles? A rectangle. Is it equilateral? And I drew it in here because I didn't have any more space on my iPad to do it. So I do my notes on the iPad. Is that equilateral? No, it's not equilateral. So no. You have to be told it's equilateral and equiangular, or somehow you have to know. Because I wanted you to realize equiangular does not necessarily mean it's equilateral. And I put mine inside my square. That is not equal. It's equiangular, but it's not equilateral. So this is just to confuse you, I think. Almost done. Okay, this is a mouthful. If polygons are congruent, in other words, they're the same polygon. If you cut them out and put one on top of the other, they'd be identical. Then their corresponding parts are congruent. Their corresponding angles are congruent. Their corresponding sides are congruent. They're exactly the same. So all the parts are congruent. If I know that I have two polygons and I know all the corresponding angles are congruent and all the corresponding sides are congruent, then the polygons are the same polygon. They're congruent. Now, by corresponding, we have to get that figured out. I want to make sure you understand that. So let's look at this example. If you look at the pictures, they don't look congruent, do they? I would have to take one of those and rotate it, or flip it maybe even. So what I'm going to do, because I don't know what corresponds to what, but I do because it's in the name. Super and great. Angle S corresponds to angle G. That one is congruent to that one. That doesn't help me with the sides. So what I do is write great up here. And remember, these are consecutive sides. So if I take side SU, which is this one right here, right? That's the same as side GR. These are congruent. Well, if I know that's 2, what does this have to be? 2. Does that make sense? Let's find another pair. Let's take UP, which is this unknown one, and it corresponds to what? RE. Where's RE? There it is. Well, I know RE is 8. These are congruent. So how long is UP? 8. And once you start seeing some patterns here, I don't have to do that correspondence. I can. What color would I use? Okay, I wanted to get PE, that's this one right here, matches up with which one? EA. So PE, so this is 5 centimeters. Now just look how this is going. This is 2, 8, 5. This is 2, 8, 5. Next one's 4. What do you think that one is? 4. Because the order has to be the way it is. Because remember, we always go either clockwise or counterclockwise, but the order has to be there in consecutive vertices. Now, notice how I use the words to figure out what sides corresponded. We're going to do that a lot this year. And if I don't have names for those, for the polygons, if I couldn't name it, then I would. I need to sign that probably. If I didn't have the names for these, then I'd name them because I can't do it any other way. Okay. Let's see what we got next. Oh, that was it. Okay, so we have a lot of vocab. What kind of vocab do we have today? We had a lot of words. Now you have to know the vocabulary. That might require you study. You could just add a sheet. So these would be. I'm just going to write it down. We had polygons. Oh no, I missed one. Sorry, I missed regular. Where's regular? Yeah, but I missed regular. Where's regular? I'm missing a slide, aren't I? No, we should have regular polygons. I did it in last class. There it is. I missed it on that slide. Can we go back to that one? Sorry, I didn't go down far enough. Because you have to know regular. And regular polygons are both equiangular and equilateral. I knew I missed something. Okay, so regular means both are true. There's only one polygon that if you know it's equilateral, it's also equiangular. And if it's equiangular, you also know it's always equilateral. Does anybody know what that is? No, squares could be rectangles. If I know it's equilateral, it has to be equiangular. The triangle. If you have an equilateral triangle, it's also equiangular. That's the only one. You have to know it's regular if you want both conditions. Because if I have an equilateral triangle, we can actually prove it now. We have some stuff. It's equilateral. What's true about these two angles? Because it's isosceles. They're equal. What's true about these two angles? These two sides are equal. What's true about these two angles? They're equal. All those angles are equal. It's the only one, though. An equilateral triangle is also equiangular. But the quadrilaterals, no. If I have all right angles, I could have a rectangle. If I have all congruent sides, I could have that rhombus. Okay? So now we'll do the vocabulary, because I messed up here. Polygons, we have equiangular. It just might help you. That's the reason why I decided to write this down. It might help you to see all the vocab we did. We had equilateral. Let's see. We had regular. We had all the different names for the polygons. Other words that were probably new? How about consecutive? Consecutive. What else did we have? Vertex. Diagonal. A lot of words here today. If you don't know what those words mean, then you don't even get half the lesson. What else did we have? Go back and look at it. Oh, corresponding. Corresponding sides and engon. Those are all the names. Corresponding sides. And corresponding angles. They got all those. Oh, convex, concave. Okay, so I'm going to go back to the very beginning and see. We've got polygons. We have all the different names. We have how to name a polygon. I think we got them all. Consecutive sides, consecutive angles, consecutive vertices. Diagonal, I think I got that on my list. There's all our diagonals. I think we got them all. But take a look at how many there are. It was heavy with vocab today. Okay, so I'm going to give you an assignment, and this is due Monday. So lesson 1 homework, and I want it on a piece of paper. Lesson 1 homework. Yeah, you might want to use your iPad to look at the pictures, because the pictures aren't as nice on my handout. That's due Monday. I will collect it. I might grade it. And guess what? All the answers are online, so you can check to see if your answers are correct.